All right, welcome to part 3. This is going to be a really important lesson to pay attention to because we're going to be going back to that formula that we've been talking about, the y equals kx, and so that can be a little bit tricky. So let's read together. Analyzing graphs. Recall that you can describe a proportional relationship with the equation y equals kx. That can only be used for proportional relationships, okay? So the constant of proportionality, this guy is that constant. And remember that he equals y over x. So that k, which is the constant, tells you how steep the graph of the relationship is. The greater the absolute value of the k, the steeper the line. Okay? So if I have a k that was a -2, and a k that was 1/2, that -2 would be a steeper line than the 1/2 because the absolute value of -2 is 2 and the absolute value of 1/2 is 1/2 and the 2 is bigger than the half. So the greater the absolute value of that k, the steeper the line. Okay? The graph in example 2 shows the relationship between the time in minutes and the number of miles Damon runs. Good for Damon, right? He's a runner. Let's write an equation for this relationship. Now, here's the deal. I want to take you through this, but at the same time, I just want to let you sit with the graph for just a second. Sit with it, notice what you notice, and see what you see. I'm noticing that when Damon is running for 10 minutes, he goes 1 mile. Okay? And so they want me to write an equation for this relationship. I could start there. I could say, okay, I know my formula is y equals kx. And I know that my k equals y over x. And so my y for this instance is a 1. And my k that's related to it is a 10. And so my equation should be y equals 1/10 x. Okay? Now, for this problem over here, for the example, they chose a different number for it. And that's okay. Because it's proportional, no matter where we choose to look at on the graph, we will end up with the same equation. So my formula equals y equals kx. And I know that that k is a y over x, right? So I'm going to look at a different part of the graph. Let's look over here, okay? And for 30 minutes, he goes 3 miles. Okay, so I've got to be careful. This is my x and this is my y. So my x is 30. So I'm going to put that in first down in the denominator. If you're used to doing the x first, just start in the denominator when you plug it in. And my y was 3. So I've got y equals 3 over 30x. Well, guess what? This can be simplified, right? I can divide both by 3, and so I end up with y equals 1/10 x. So, looking at this, my equation for this graph is y equals 1/10 x. Think about the reflection question down below. What do the points 0, 0, and 1, 1/10 on the graph tell you? Think about it for a second. And in this case, it's going to be really important for you to use your units. And make sure that when you're talking about these, that you're talking about the x, your coordinate points, you're talking about the x first and then the y second. So when he travels, or when he's running for 0 minutes, he's traveling 0 miles. And when he is running for 1 minute, he travels 1/10 of a mile. That's how you answer those questions. Make sure that you use your units on your graph. Make sure that your coordinate points are always listed as x and then y, compared to your k, which is the opposite, which is y over x. Okay? Sound good? So suppose you drew a graph representing the relationship y equals 1/8 x between the time in minutes and the number of miles Esther runs. How would that graph compare to the one for Damon? So think about what they just told you at the very beginning. Think about it for a second. How would the graph look for 1/8 with your constant being 1/8 versus 1/10? Looking up here, it says the greater the absolute value of k, the steeper the line. This 1/8 is our k, right? And the other k was 1/10. And so which one is bigger, 1/8 or 1/10? You got it. 1/8 is bigger, and so 1/8 would be a steeper line. Okay? So Esther's graph would be steeper. I really like question 4 here. It says, use your equation to find out how far Damon can run in, let me get my colors off there for you. Okay, use your equation to find out how far Damon runs in 40 minutes. So our equation was y equals 1/10 x, right? And so we want to find out how far he runs in 40 minutes. Well, our minutes, were they the x or the y value? Yeah, they were the x value. So all I have to do here is replace this x with 40 minutes, and then I'm good to go. Since what's happening between this 1/10 and the x? Yeah, they're being multiplied. So I rewrite my equation as y equals 1/10 times 40. And so if I'm multiplying times 40, I'd put this over 1. I can cross cancel. I end up with 1 over 4. And I can simplify this to y equals 4. And this would be, units would be miles, right? Because my y is in miles. Okay? So then it says, so that's my first answer. And then how much time would it take him to run 7.5 miles? Let's see. So I can rewrite my equation. Y equals 1/10 x, right? But this time I was given the miles, and that's my y value, right? And so this is 7 5/10 equals 1/10 times x. And so in order to get this x variable by itself, I've got to get rid of this, right? So in order to get rid of this, I am going to multiply times 10. Do you agree? And so I multiply by 10 over here. All right. And so I multiply times 10, multiply times 10. And so I've got 75 equals 1x, which is just x, right? And so this 75 is really 75 minutes. So an hour and 15 minutes. I could write it as either 75 minutes or an hour and 15 minutes, but that would be my second answer. Okay? I want you to try the your turn question by yourself. Pause the video and then listen to my explanation, okay? It says the graph shows the relationship between the distance a bicyclist travels and the time in hours. What does the point 460 represent? All right, so if this is my 4 is in the x place for my coordinate points, and my y is the 60. So for these types of questions, all I have to do is look at my units. And so the point 4, I look at my x, and that was hours. And so it takes 4 hours to go 60 miles. And so you'd put that in a full sentence. It takes 4 hours to travel 60 miles, okay? What is the constant of proportionality? All right, so that constant is the k, all right? And so we know that k equals y over x. So if we find the k. This is all they want. They want the k. So I've got to put a y over x. So I've got to find one. I'm going to look for one that's easy to read. Like this guy. You see how it's not in the middle? You see the one for the 1 hour is kind of like, I don't know what it is, 17 and a half, 15? I'm not exactly, no, 17? Somewhere in there. But that one's a little difficult to read. But this one for 2 looks like it's at 30 miles. So 2 and 30 miles. Do you agree? Oh, it is 15. I see it now because I was looking at the chart wrong. So if I take the 2 and the 15, I've got to put my y over my x. So be careful of that. You might even want to like put a note for it every time. K equals y over x. And so my x, I'm going to start with my x and put it down in the denominator first. That was 2 and my y was 30, which equals 15. And so my k equals 15. The k equals 15 is my answer here. This will be on your test, and I do not want the formula for the question like this. I just want what k equals, so please be careful about that. And then it says write the equation in the form y equals kx. Well, we know what k is, right? And so we just plug that in. So y equals 15x. And since it's proportional, it's a straight line, it's going to go through that origin, then we know that we're okay. We could also check it by grabbing another number in here. The 4 and the 60, right? 4 times 15 equals 60, and so it is proportional. It checks out. Okay? Go ahead and finish the rest of the math pages for your classwork and for your homework, and get some practice in. You can ask a neighbor if you have any questions. Have a good day.